stunning death of a star. JWST captures the beauty of a planetary nebula. Imagine the awe-inspiring sight of a star, once a blazing beacon in the cosmos, now in its final act. A breathtaking planetary nebula named NGC 6072. A celestial masterpiece painted by the dying embers of a star. It's a transformation as beautiful as it is mysterious, and it's a glimpse into what our own sun might one day become. But here's where it gets controversial. This stunning splash of colours in the Scorpius constellation, captured by the James Webb Space Telescope, JWST, reveals a shape so complex that it's clear there's more to this cosmic transformation than meets the eye. NGC 6072 isn't just a simple round nebula. It's a misshapen splodge, with multiple outflows of gas and dust streaming out in various directions. Think of it as a cosmic dance between two stars. Tens of thousands of years ago, the more massive of the pair began to falter. As its nuclear furnace faltered, the outer layers began to collapse, heat up, and ignite, ejecting themselves into space to form the nebula. What's left is a white dwarf, the star's exposed and scorching core. But what's truly fascinating is the interplay between the two stars. The JWST's near-infrared camera, NIRCam, shows us multiple outflows, each pointing in different directions. Is this due to the gravitational tug-of-war between the two stars? Or is it something else entirely? And then there are the colours. These aren't just pretty hues, they're clues to the nebula's secrets. The dark orange clumps are remnants of the star's mass, while the blue regions are relatively empty, dust-free areas. The JWST's mid-infrared instrument, MIRI, reveals concentric rings, possibly carved by a companion star or the dying star's pulsations. But here's the part most people miss. Even the JWST can't resolve the two stars at the heart of NGC 6072 as separate objects. They're too close together, hidden behind a veil of dust and gas. This cosmic spectacle isn't just a beautiful sight. It's a window into our own future. About 5 billion years from now, our sun will undergo a similar transformation. So what do you think? Is this the most beautiful death in the universe? Or is there something even more mysterious at play? Share your thoughts in the comments below. Join the conversation on our space forums. And let's explore the wonders of the cosmos together. And if you have a news tip, correction or comment, we'd love to hear from you at community@space.com. Keith Cooper, freelance science journalist and editor, with a degree in physics and astrophysics from the University of Manchester. Author of The Contact Paradox, challenging our assumptions in the search for extraterrestrial intelligence. Bloomsbury Sigma 2020. JWST discovers third supergiant star in Apep cosmic Serpent system. JWST has uncovered a cosmic enigma. The Apep Nebula, known as the Cosmic Serpent, appears to be devouring its own tail. Or perhaps the tail, comprised of vast dust shells, is being consumed by its half-sibling in a tale that feels straight out of ancient mythology. This system could hold the key to unlocking the mysteries of how much of the dust in early galactic development was formed, which in turn shapes the birth of planets. Imagine a universe brimming with wonders. Yet Wolf-Rayet stars still stand out as extraordinary. These stars represent the final phase certain giants undergo before exploding as supernovae. They emit powerful stellar winds that strip away most of their mass. When these winds collide with winds from other massive stars, they can cause carbon atoms to clump together, forming dust particles. Massive stars often form in pairs, as noted by Macquarie University student Ryan White, who co-authored a preprint paper. However, even the largest stars rarely reach the Wolf-Rayet stage, and for those that do, the process is fleeting by cosmic standards. Thus, in the entire galaxy, we know of only one system where two Wolf-Rayet stars orbit each other closely enough for their winds to collide. Now, the James Webb Space Telescope has given us a glimpse into the inner workings of this celestial marvel. The Wolf-Rayet pair and their surroundings are called Apep, named after the Egyptian snake god. What makes this system unique is not just the Wolf-Rayet stars, but also the distance between them. While other colliding wind nebulae have stars orbiting closer than 10 times the Earth-Sun distance, Apep's primary components are about 100 astronomical units apart, roughly 10 times farther, and take 193 years to complete their orbits. Most of the time, the stars are too far apart for their winds to create dust, but their orbits are highly eccentric. Around their closest approach, immense clouds of dust form, likened to puffs of smoke. These puffs gradually expand outward, while the very large telescope has imaged the innermost shell. It lacks the sensitivity to detect older ones. The JWST, however, has revealed 3 innermost shells, going where other telescopes cannot. Its observations show winds racing outward at 2,100 kilometers per second from one star, and an astonishing 3,500 kilometers per second from the other. Studying these images, White and colleagues discovered a massive cone carved into the shells, traced back to a neighboring O-type supergiant star. This star, born with less mass than the Wolf-Rayets, is now the largest mass in the system, due to the pair's material expulsion. The supergiant's power is staggering. Even at 1,700 astronomical units away, it's somehow destroying the dust the Wolf-Rayets are creating. White admits the team hasn't fully explained this phenomenon. Probably many things are happening in parallel, he said. It's wind colliding with dust, but this star's brightness emits huge amounts of X-rays and UV light, which may be destroying the dust. The O-type star's vast distance once raised questions about its connection to Apep, but identifying the void it carves in the nebula settled that mystery. White suggests it's likely, but not confirmed, that the 3 stars formed together, with their higher initial mass causing the inner pair to evolve faster. Reaching the Wolf-Rayet stage first, they'd be no older than 5 million years at most, he added. A Wolf-Rayet stage lasts under 100,000 years, but we don't know how far through this pair's cycle they are. Could fireworks follow soon? Researchers have studied other galaxies, but results are inconclusive. We have a better idea for red supergiants, White noted. Though Wolf-Rayet pairs are rare today, giant stars were far more common in the early universe. When the Milky Way was forming, systems like this were probably widespread. Much of the dust we see in giant clouds and streamers today may have formed under conditions like this. 2 papers on the Apep system are pending publication in the Astrophysical Journal, with preprints available on archive.